Okay, in this lesson, we're actually just going to review everything we've talked about so far. So I'm just going to kind of go through this. What is a rational number? Well, it's a number that can be represented as a fraction. So like 1/3, 1/4, even 4/1. It includes all of your integers, all of your whole numbers, everything. Now, rational functions are a function that can be represented as a fraction. So I'm not going to really write down all of these, but we can. A function that can be represented as a fraction. Remember, and it's a polynomial divided by another polynomial. What is an asymptote? Well, an asymptote is an imaginary line that the graph does not touch. When does a vertical asymptote occur? Well, that occurs when the denominator equals 0, because you're dividing by 0. Now, what causes a function to get really big, either positive or negative, when you approach that vertical asymptote? So why is it making it shoot up or shoot down? Why are we getting that behavior? Remember, as the denominator gets smaller or approaches 0, the fraction as a whole is going to get bigger and bigger and bigger. So the fraction approaches infinity as your denominator gets smaller. So when you divide by 0.000001, you're actually going to get a big, 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 big answer. When you divide by a smaller number, your fraction gets bigger. And conversely, if you divide by a bigger number, your fraction gets smaller. Now, how do you find the x-intercepts of a rational function? You set the numerator equal to 0. How do you find the y-intercepts? Well, that one's the easiest one. Let x be 0. Now, to review the end behavior of a function, if the degrees of the numerator and denominator are the same, like if we had 4x plus 1 over x plus 3, describe the end behavior of the function. This is going to be a horizontal asymptote, and it is found by dividing. Divide the first terms, or the leading terms. Let's put leading terms. Now, the numerator has a smaller degree than the denominator. So let's say this one's just got an x, but this one has an x squared plus blah, 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 blah. Remember, the numerator is smaller than the denominator. And that means we're going to end up with dividing by a variable at the end. And as x gets bigger, that means that denominator is getting bigger and bigger and bigger. So in that case, you will always have a horizontal asymptote at 0. It'll always be that way. Now, the last type is when the numerator has a larger degree than the denominator. How do you determine the end behavior? Well, how do you determine it? You divide. If you divide, you're going to figure out what your end behavior is. Now, your options are, you could have a slant, you could have a parabolic. It just depends on what your answer is. Now, I want to do a couple of examples. X-intercepts. We find our X-intercepts by looking at the numerator. Now in this one, it looks like this might be something I could factor. So I'm going to go ahead and factor out the 2. I'll get x squared minus x minus 6. And I bet that factors again. X and x multiplies to be negative 6, adds to be negative 1. That's going to be a negative 3 and a 2. So this one has 2 X-intercepts. It's going to have 1 at 3 and 1 at negative 2. Now, the y-intercept is where you let x be 0. So that'd be 0, 0. I'd have negative 12, and then just a negative 4 on the bottom. Negative 12 divided into negative 4 is just going to be 3. Vertical asymptotes are found by looking at the denominator. When is the denominator going to equal 0? That's when x is 4. In behavior, as x gets bigger or smaller, my in behavior, I will find this by looking at the first terms. So the first terms, we have 2x squared and an x. If I divide, I get 2x. So it's going to behave like 2x. In other words, this one's going to have a slant asymptote. My next example, again, it'd be helpful to factor. So I'm going to factor out the 3. In the denominator, I can factor out a 4. See if we can go again. Ooh, that one's nice. X plus 4, x plus 2. In the denominator, that's going to be x plus 5 and x minus 2. All right. X-intercepts are found by looking at the numerator and seeing what makes it equal 0. It's easiest to see it there. Negative 4 and negative 2. The vertical asymptotes, those are easier to see in the factored version as well. I would have x equals negative 5 and x equals 2. Now, for the y-intercept, we're going to let x be 0. This one is actually easier to see in the original. These have x's, so those all go. I end up with 24. Let's see, 24 divided by negative 40. It's got an 8, so it's negative 3/5. So my x-intercept is 0, comma negative 3/5. In behavior is found by dividing the first terms. So I have 3x squared over 4x squared. That's just going to give me 3/4. So this one, as x goes to positive or negative infinity, f of x is just going to go to the number 3/4. In other words, we're just going to have a horizontal asymptote. Last one. 2x minus 6 over x plus 1. Ooh, this one's nice. X-intercept is going to be 3. Vertical asymptote, we look at the denominator. X equals negative 1. Y-intercept, you let x's be 0. So I get negative 6. And the end behavior, as x goes to positive or negative infinity, f of x is going to go to, I'm going to divide. 2x divided by x. 2. All right, so this makes it a lot easier to graph. Our x-intercept is at 3. Y-intercept is at negative 6. So we have our intercepts. Vertical asymptote is at negative 1. Horizontal asymptote at 2. So I know this side's going to do this. That means this one's going to do this.